Hey everybody, it's Ben here, and today I want to show you how to light up a light bulb with a cordless tool battery. So in front of me here, I've got a number of 3D printed objects. I just recently got myself a 3D printer. I was very excited about that. I got an Ender 3 S1. It's got a lot of great features, auto leveling, it's real nice and quiet. Couldn't be happier. And I wanted to try a little bit of 3D printing, but I wanted to be something practical, you know, not just making little bunnies or something goofy like that. And I've been playing around a lot with Ryobi batteries. I've used these for a number of projects, like a little motorbike, an electric wheelbarrow, some things like that. And in fact, there's already some connectors that actually work really well that way. You can buy these online. They're usually listed as a Power Wheels adapter. But if you're buying a bunch of those are going to get a little bit expensive. And with 3D printing, you can do anything you can imagine custom, as long as you have some basic 3D skills to design an object itself. But the first thing I did was I went on Thingiverse to look for some power adapters that I could 3D print instead of having to spend my money on this sort of thing. And I found a real basic one that I really liked. It's just a little plastic cap here. And if you look at it, just the shape of it allows you to poke a couple of wires through, and then those wires go directly onto the top of the battery. And in fact, just the shape of it actually makes it fit on pretty nicely. So this is a great, very low-tech way to get power out of the battery. Now, of course, I want to be careful not to short these wires right here, and you know, putting a fuse on there right away is a good idea. I just used some doorbell wire here, solid 18 gauge, and it seemed to work okay. Then the next thing was I found another object on Thingiverse that I really liked, which all it was just a light bulb socket. And that object also just used some plain wire for the conductors for the socket. So if we look here, you can actually see a wire crossing the bottom of the light bulb socket and another one that goes up the side. And of course, what that does then is it makes the connections at the tip and the side of the light bulb, which is where we need them. But still really low tech. I mean, it's just some wires. Fantastic, right? So what I did is I basically just printed those two objects out, stuck them together, and then fished some wire through, and then covered the whole thing with some white electrical tape. And this is what I ended up with right here. It's not perfect. I mean, it's got some tape on there. It's not a single 3D print, it's two. But at the same time, it turned out pretty good. I've got those power connections, which are just wires going over those humps that fit onto the battery. And then on the other side, we've got those wires for the light bulb. So if I thread this in here and then stick it on the battery, sure enough, we've got power. So I took a couple of photos of this project, I put it up on social media, and I got a lot of really good, positive comments right away, which I was very, very excited about. But then I thought, what would be better is if this was just a single 3D object instead of two. So I tried my hand at just sticking together two STL files, and the result was this, which is not fantastic. This, I just happened to be using a different filament, so it's this kind of silver gray. And this one used supports, and the supports pulled out the bottom where they'd have to go into the battery real easy. But I accidentally also filled in the little holes where the wires to go to the bulb socket would be, and I've got no way to get those out of there. Maybe if I drill this out with like an 1/8 inch drill bit or something, maybe I can work. Anyways, it was not a fantastic bit of 3D design right here. But one of the guys on social media said, hey, you know what? I could just stick those two files together for you. So thank you, Chris, for doing that. And the result of that was then this version of it, which is just one piece. So we've got our two sections. We've got our socket here, and then the connection for the battery here. And then the other thought, I didn't want to use the wire just because it's a little goofy to deal with. Now, the nice thing is it's something a lot of people might have in their garage or basement or workshop, so perfect that way. But it's not too much more difficult to get yourself some nickel strips. These are some nickel strips that I mail ordered. I used them for a nickel plating project, and they're commonly used for things like 18650 battery pack builds. Guys will use these nickel strips to spot weld between small rechargeable lithium batteries to build like electric bicycle battery packs, for example. Now, this is pretty thin material and it cuts very easily with the scissors. So I just simply cut a couple of those strips in half, and then this project is designed so that you simply slide the nickel strip through there. There's some nice little pockets to kind of hold the ends of the strip. And we go from the little humps on the side for the battery, and then those go right up for the tip of the light bulb and for the side of the light bulb. You can see how this strip here, it actually follows the contours of the threads. Now, on this particular one, you'll also notice that it's cracked right here. This version, the top part was actually a little bit too small for the light bulb, so when I threaded it in, it ended up cracking. Chris made a newer version, and that's the one that I've got right here. And instead of that rounded edge, it's squared off. A couple other little minor changes. But basically now it's all ready to pop right onto the top of a battery. This here is squared off, it's a little bigger. Another little trick that I found dealing with 3D printing, if something is off by a tiny bit, it doesn't quite fit, but it's really close. A lot of time, and especially threads, this is a big one, you can just heat up your 3D print a little tiny bit, just like a hairdryer or something, and then thread your object into it. So what happens then is it doesn't take a lot of heat for the PLA to get soft. You thread the object in, and if it's just a tiny bit off, it just takes the shape absolutely perfectly. So in fact, as it is, this was the version 5 of this 3D print file, which was still a little too small for the light bulb, but just heating it ever so gently really worked very well to get those threads absolutely perfect. And so now I've got a light bulb that I can just pop onto a battery pack, and essentially we've built a very small, simple lantern. Now at this point though, I bet you're saying, well, wait a minute, how can you do that with a light bulb? A light bulb is 120 volts AC, right? Well, typical light bulbs are, but there's a lot of other types of light bulbs out there as well. The big thing is landscape lighting light bulbs. There's a lot of lighting done outside of people's houses, and typically that's low voltage, often 12 volts, and typically that's actually AC. So if we look on the light bulb here, we will see that this one is listed as 12 volts nominal. But the thing is, it'll actually run on AC or DC. And if we look on the actual box itself, this one says that the light bulb will run on AC or DC from 10 to 30 volts. So that's perfect. We've got a DC 18 volt battery. We've got a bulb that can handle it. We've got a 3D printed connector to make everything work together, and some simple little pieces of nickel strips for our conductors. And boom, we now have our 3D printed light. I just thought that was pretty cool. I was just really excited, had fun to kind of go from concept to creation in like a day total, get a little bit of collaborative help online from somebody else. Check out the description of the video. I'll have the links to the STL files that I'm talking about here. I'll give some links to the light bulbs too, just because I know not everybody's familiar with this type of light bulb, but you can commonly find them at like your big box home improvement store in the lighting section for landscape lighting. Just one more thing I forgot to mention, and that is this is a 4 amp hour battery, and when we look on the back, it does list the capacity in watt hours at 72 watt hours, and this is a 7-watt light bulb. So this, running on a fully charged 4 amp hour battery, is about a 10-hour runtime. So basically that'll take you overnight, no problem, in any emergency camping or however else you might use this product. But just this little thing, hey, I got a cool backup emergency lighting device. I can use it for going camping, things like that. And this whole thing cost me less than a Ryobi flashlight or a Ryobi lantern or even just a power adapter here. So it's kind of fun, save a little bit of money, come up with something myself. I hope you like this project. I hope you like this kind of stuff. If you do, please like, comment, subscribe. Check out more information on this over at 300mpg.org. And until next time, stay charged up.